I think we should kind of expand now by jumping over into the package management and create a new package. We're just going to call this package managers. Keep in mind, when you're working with Java, bad habit of people is to think that yes, you are making directories, but you're not making actual directories for you. You're making packages. And by saying that, make sure you're using, the standard protocol, or rather the standard style guides for the syntax of everything, and following common practice. By saying that also is these need to be lowercase. I see a lot of examples where people are making packages and they're uppercase, they're capitalized, and you shouldn't do that. Not necessarily because it'll ruin anything, but just for sharing code and whatnot. It's just the common way Java developers do things. So just some insight again into the industry, just so you guys know. And so now we'll go and make a new Java class in that managers, and we're gonna call this our GameScreenManager. Ooh, this is gonna be good. And again, if you guys if you're having a hard time reading the code, please let me know as soon as possible. If this is too low not resolution, but if it's too small of a font, I'm more than willing to increase the font. I just don't have any fancy controls like some people do, where they zoom in and whatnot. And sometimes I feel like that gives people, I know it gives me a little bit of motion sickness by moving and panning the camera, zooming in and everything. But if you can't read this from just this point of view, let me know in the comments below. I really appreciate it, just so everyone can read things clearly. And I might even change this to the white color, because dark yellow can be a little dark, but I haven't really heard any people having trouble so far from reading my code, even on my smaller screen. So let me see. So we have our GameScreenManager. That's all good. And now that that's made, let's just get it at least declared in here. So we have it under our managers. So public GameScreenManager, and we're just gonna call this GSM. And that's just kind of a common name that I give that. Like Game State Manager, Game Screen Manager, anything like that is normally GSM shorthand. And the public constructor, GameScreenManager, and like I said, this is going to take in the main application, so it can kind of pass down those references to the sprite batch, to the asset manager, and to the audio manager, and all those good things that are in our app. And so that's going to be a final reference, because we really only have one application running of our game. And so final application, we're just going to call it app, and then we need to make that reference up here. So that's going to be private final application app. That's going to be this.app equals app. Okay, perfect. So now we can go back into our application class and come down here, and right above our asset manager, we're going to have our GSM equals new GameScreenManager, and we'll say this because this is our application instance. So so far so good, right? We're all kind of moving forward now, and we're actually messing around with the code. So now we should start taking some time to think about how we want to set up our GameScreenManager. We want a effective approach to setting the screens of our main application, and also preparing ourselves down the road for when we want to do those fancy screen transition effects. Now, I did mention that we don't really want to be thinking ahead too much on implementing all these new things, but it's still something good to keep in the back of your head, so you don't code yourself into a wall and make some kind of spaghetti code monster that you can't really refactor in later on. So we're gonna think about this appropriately, but not go overboard. So I do already have some stuff written that I think will just be a good start for us. But if anything, the first thing we need to think about is getting an abstract game screen. That's going to be our next step. So we have like a screen we can test out our idea in, our game of Pong, or get our prototype set up, and then we can from there make more screens and kind of implement the rest of our game, build it up, and add our effects. So let's see, we need so we got our application in here, and we need to have, you know what, let's just make that abstract screen that I was talking about. So we need a new package, and we're just going to call this screens. And so in our screens, we're going to have a new class, and we're going to call this abstract, no space, abstract screen. All right, and we can get rid of that top automatic comment in there. So now that we have our abstract screen, this abstract screen is going to, or I think it's implements, and that's going to be the screen interface that bad logic gives us. And yep, there it is. Good to go. You'll notice we'll get this red squiggly line, and that is because we have methods that we need to implement. We are also going to make this an abstract class because we do want to have a few methods in here that we are writing ourselves that the subclasses will implement. So I think one of them I had was like the update method. As I mentioned to you guys, like it's good to separate your update logic and your render logic just so it's clear and you don't get the two mixed into each other. So we'll see that in just a second. But first thing first, we are going to have a protected final GameScreenManager reference, and we are going to call that GSM. We will also have our constructor, so public abstract screen final GameScreenManager, well, not game, GameScreenManager GSM. And we could just send it the app as well, but I'm just gonna pass it the GSM for the sake of, you know, getting that downward delegated flow. So this dot GSM equals GSM, and I think that's all we needed for that. And then we're also going to have, like I said, we want to have that update method. So we're going to create an abstract method that all subclasses will have to implement. That's going to take a delta. What this is, if you haven't seen it before, if you're just joining me now, the delta is typically used to make sure your game runs, like if you have any kind of physics operation or calculations that are going on, it will kind of accumulate a delta between frames. So the delta is the difference in time, or how much time it took to get to the next frame. So like how much time did it take to get to the next call of render. And while that is typically milliseconds, sometimes, you know, you're doing a lot of heavy calculations or something got clogged up in your logic and it's taken a long time, and then it finally makes it through and gets to the render. That time that was spent will be accounted for, and your physics engine will know to accommodate for that and make sure everything is updated accordingly to where things should have been at that time, instead of running unrealistically slow and out of sync with real time. So that's a little bit of a vague description, but it's something to be aware of, and it's definitely something you should use often to help in your calculations when you're doing those like time steps and everything. So let me think. Next, we have our all screens. Oops, actually, we are in the GameScreenManager. We need to be in our abstract screen. All screens have a render method, and our render method, we're going to override the one that you would typically use by, instead of overriding it in the subclasses of AbstractScreen, we're going to have a superclassed render method in here that the subscreens will do a super call to, but also have their own. So we're going to do an @override annotation, and there's going to be public void render float delta, and then in here we're going to call that update method that we had. And then we're also, I was thinking about it. I did this in my project that I'm working on the side, but I'm not too sure if I want to do it here as well. Just kind of depends on how we're feeling about it. But I was thinking personally that we could just have the have this code and just take it out of here and just put it in here. I don't really feel like that might be necessary, so to speak. But I was also thinking like we would be calling this in every subclass of our screens. So maybe just for the time being, just so we have a place for it, we can get it out of our main class. Import that. And by the way, I'm importing things by holding our Alt and then pressing Enter once the prompt comes up, if you're curious, for IntelliJ. Or I believe you can also, so you can right click and then, oh gosh, where is it? Wait, it wasn't even there, was it? Right click. I know it's in here somewhere. You're able to kind of generate the, okay, well I guess it's not there. So yeah, just do the Alt Enter trick. And so with that, we have our special render method. So now when we make our subclass screens of this abstract screen, we'll have this render method that we'll call super to, and it will call update for us. So we don't have to have our render methods looking kind of ugly like this in every single screen. We just can separate out our render and update right away in our subclass. So we'll never have to touch this kind of skeleton looking file. It's doing all that dirty stuff for us in the background and kind of making that flow work for us on our end, so we can not really think about this boilerplate anymore, because this does look contradicting, like render and update, to me at least. But it's the way you kind of have to do it if you want it to look nice on the actual subclasses. So we're also going to have a dispose method. So override public void dispose. And you know what? I think I'm just going to introduce this to you guys right now. We are going to have a stage for pretty much every class, I imagine. Everything will typically have some UI elements or something going on. So the stage isn't really all that expensive. And so this dot stage equals new stage. Perfect. So we'll have a stage we can work with for every single subclass. We might change that down the road. Who knows? Just, again, depends on what happens. Refactoring isn't necessarily the hardest thing, especially for negligible things like this. So we'll have a stage to work with at least in every context, and for every stage you must dispose of those stages. Again, make sure you're disposing. Always watch for that. And I guess if we're doing that now, we might as well also have our resize method. Void resize, that's going to be int width, int height, and then stage.get viewport dot update, and that takes a width, a height, and true. Okay, so that just takes the width, the height, and I believe it updates or recenters the camera or something. But that's again not really important right now because we're not even going to be touching viewports yet. But this is just to take care of it, so when we do subclass, we don't have to have the resize method in our subclasses. It's always getting done here for us, so we don't have to think about it. So yeah, this is pretty much what our abstract screen will look like. It's got a lot of stuff taken care of for us already. It's got our flow kind of figured out, and now we can at the least go into new, create Java class, and create that game. This was another thing that I was actually curious to think about how I wanted to name, and I think I'm gonna call this the game screen. Yeah, might as well do it. So I'll just go for that. Typically, I think I normally name it like the play screen, but play doesn't sound as right as game should to me. Again, that's just all personal preference. You can name it whatever you want. Could be Pong screen, could be not main menu screen. So, well, don't really choose that, but just saying. And so now that we have our abstract screen, it is an abstract class, and because we have some abstract methods, when we subclass it, we have to implement those abstract methods. So with classes, not interfaces, you would use extends because we are not using an interface. With an interface, you use implements, as you see here, where it's just a bunch of empty methods that you have to implement, but we are using an abstract class. So we're going to extend that abstract screen, and you'll see we get that red squiggly line again. And that is because, like I said, we have a method in particular that we have to implement ourselves because it's an abstract method. It doesn't know what that is, but it knows it needs one. So we have to go back in here and do that Alt-Enter, and you can implement those methods. You'll notice we're getting some other things too that we weren't really expecting. There's the show, pause, resume, and hide methods that are coming along with this. And you'll see that the update method is there that we made, and it is under the AbstractScreen class. However, the screen interface is also coming along and telling us, hey, you need to implement these methods. They weren't even implemented in your super class. So you really got to take care of this. So we hit OK, and it brings in all our methods for us. You'll notice typically that like if we didn't have these overrides here for the dispose, if we didn't implement dispose or resize or render, those would also be in here. But because they were implemented in the super class, they aren't required to be done here. So it just uses the super classes calls. But we will be overriding those and just calling the super classes methods along with our own game logic in here. So just to kind of show you guys real quick, we have a show, pause, resume, hide. Let's see. Yeah, I like to put it the update method. I'm actually going to move. I like to put the show method above everything, but the pause, resume, and hide normally just end up floating towards the bottom. So we got our update method, and like I said, we're gonna override that render method, public void render, and that comes with a float delta, and that is going to have our super.render with the delta. And so what it's doing here is it's using this game screens like anything else we introduce here. It'll just call this first, which is coming from this abstract screen, and it's going through this stuff. It'll call this code first, and then it'll do our work. So that's just kind of that design going on right there of how we have this set up. Now we want to, what else? Oh, we need a constructor. So public game screen, and that is going to take a, let me think, that's going to take a GameScreenManager. All our game screens will take a GameScreenManager, and that's going to be super GSM to understand this. So you notice how we have the super and then the dot. Whoop, that did not work right. Super dot render. That's because we're calling the super class, so a reference to this class, and then as normal, you know, when you're calling a method of under a class, so like this dot dispose, and that's kind of what's going on there. But you see here, it's super with some arguments, not doing the dot. That's because we're using the super class's constructor. So you'll notice we have public AbstractScreen, and then we have this final GameScreenManager GSM. That's just kind of doing what you see here. So we're passing the GSM that this game screen is going to get to our super class, which sets it to our protected GameScreenManager reference, and it moves forward. So now we have a initialized GameScreenManager at this point, and we can say like this.gsm.app. Oh wait, GameScreenManager private final. Oh, this should have been public actually. There we go. Yeah. So gsm.app. Now we have access to the assets. We have access to the batch. We have access to the shape batch and all that good stuff. And we'll have access to the audio manager. And again, I might change it around to where a game screen takes an app. So we just have to call the, we'll just say like this.app. That actually, you know what, that actually sounds good. Why don't we just do that? There's no reason to call or have the GameScreenManager reference passed around, because if we have access to the app, we'll have access to the GameScreenManager because it's public anyway. So yeah, that actually makes more sense. So let's do that. That sounds a lot better, since the application is housing everything anyway. And so that's going to be app and Alt Enter, get my application, pass it the app, make some changes in our abstract screen. This is going to be app now. And this is going to be application. This is going to be app. Sorry for the refactoring here on the fly. It's just a last minute decision. And there's that. And this is going to be this.app equals app. Okay. We can clean up our imports here by pressing, well, I'm on a Mac, so I press Command Alt L. It might be Windows Alt L for cleaning that up, but you might have to look up the respective shortcut for that. Sorry, I don't know that for Windows. But it is a nice thing to have because it just automatically formats all your code for you. And then in our GameScreenManager, we haven't really done anything there yet, and this is all fine as well. Okay, cool. So now that we're using our app in our game screen, now we can do app.gsm.set next screen or perform transition, that kind of stuff. We can stop or play, that all, everything. We have access to every single thing now. The visibility of that doesn't matter because those are top level coordinators that are controllers that we should have access to in our game, because they really house the functionality of how to control what we're setting up. And we want to be able to do that anywhere in our game. Like if we want to transition to a new screen, we need to be able to tell our game to do that from somewhere. We don't want to have to say like, okay, perform transition and send that to our GameScreenManager and be like, okay, the GameScreenManager is like, okay, I got to tell my application now perform that change. And I mean, we do have that kind of workflow, but we don't want it to be that hard to do these big ideas that really don't need to be that complex, and we don't want to make it add too much overhead to it. So you know what, I believe with that, now that we've kind of gone over a lot of stuff, I'll just kind of review now, just so you guys can let it sink in of what we've done so far. And I think I'll delegate the material of getting our first screen set up and getting our GameScreenManager set up in the next video, and that video will probably also have us getting our first stage set up. So just so we can see what we've done so far, we made a few changes and got some understanding looking into the desktop width and height, and then understanding a little bit about virtual width and height. We set up two of our managers so far, our GameScreenManager, which we'll start looking into later, and our Asset Manager. And we also have our sprite batches set up. We initialized all 4 of those things so far, and we changed our class to the game type and call that super.render so we can work with screens. And we also have, we commented this out because we moved that code, that buffering, so we can actually move that comment as well. And then we learned a little bit about the dispose method and why you should always dispose of anything you can. And also think about the order that you're disposing. And I say that because if you dispose of a resource that's currently being used by something that's not, how to describe that right? If let's say that the texture that you're using, you have like a texture. If you dispose of that texture, or if you dispose, or yeah, a better idea might be if you dispose of your assets before you, like, the texture's disposed, I guess might be a good way to say that, then you're gonna have a problem where it's like it doesn't know how to dispose of that texture because it was already disposed of, or the reference that it had got disposed and it doesn't know what to do. You can run into errors like that. So just be aware of the order here does matter for disposing of some things. Sometimes it's like a little, like, not really, it doesn't really care or it doesn't really matter, but when you have a lot of stuff being disposed, just make sure you're doing it in like a reasonable order. And if that gets any bigger, we'll definitely touch on that a lot more, and I'll even probably try to make it break so you guys can see like what instances cause that. So yeah, we learned about the dispose method. We made our GameScreenManager, clean that up a little bit. We're passing around a reference to our application, and we'll be passing that application down to our game screens, which we have here, and you'll see we have a reference to this app, which gets sent to our super class, the AbstractScreen, and this kind of houses our good core functionality of what we're looking for. We separated the render method into two methods, more or less, so we can separate that logic of our update and our render logic as well. And then we just have a simple stage. We'll probably refactor that down the road once we touch on the viewport stuff and whether or not we actually do want a stage for every single screen. That will come into question once we get further into our app as well. So we've covered a lot of the groundwork. I believe like I said, all that's really left is to get our first stage going with maybe even our box 2D world going, maybe something basic just to have it set up, and then we'll just keep moving from there. And so with that, like, comment, subscribe as usual, and again, tell me if you're having trouble seeing the font. I will do anything I can to help you guys to accommodate to really figure this out. Again, I'm still playing around with stuff. I got this new screen and I'm just hoping you guys can see everything. So with that, I hope you guys enjoyed the video, and I'll see you next time.